Okay, so welcome back, and now we're going to start the topic of what we call initial value problems, now, or IVPs. So before we talk about IVPs, let's talk about what this is. This is what we call a differential equation, okay? Now this is a very simple example of a differential equation. So what is a differential equation? A differential equation is an equation that involves an unknown function and one or more of its derivatives, okay? So the solution to this differential equation here is y, some function y equals f of x plus c. So in other words, we're looking for any derivatives. So any derivative of this form that satisfies this differential equation is a solution to the differential equation. Okay? So for example, if I had this, dy dx is equal to 6x squared, then what we would say is the solutions to this, right? So y would equal the integral of 6x squared dx. So we would integrate this and find the antiderivative. So the antiderivative, again, using this would be 6 divided by 3 x to the third, or 2x cubed, okay? Plus c. And so this family of solutions, okay, or family of functions are solutions that satisfy the given differential equation. Okay. Now, sometimes we are interested in determining whether a particular solution curve, right? So this represents a whole family of curves, and sometimes we're interested in whether a particular solution curve goes through a given point. Okay? And so the problem of finding a function y that satisfies a differential equation with an additional condition, right? So in this case here, let's go back to this. So, like, we want to find whether a particular solution of this goes through a particular given point, x naught, y naught. Okay? So, in other words, the way this would be set up is we would be given an additional condition, which would be, say, for example, how would I write this? Y of, yeah. So we would do y of x naught is equal to y naught. Okay? So we would set it up like this. So this would be an example of an initial value problem. The condition y of x naught is equal to y naught is known as the initial condition. Okay? And this is what allows us to be able to solve or to see if a particular solution exists for this differential equation with the initial condition. So for example, if we go back to the example I just did. So we have dy dx is equal to 6x squared, and let's say we are given the initial condition of what? Y of 1 equals 5. Okay, so now, this is an example of an initial value problem. So now what we're going to do is we're going to solve for the differential equation like we did before. So we know that the integral of, or so y equals the integral of 6x squared dx And so that's going to equal what? 2x cubed, okay, plus c. Now, we know that y equals 2x cubed plus c represents a family of functions that satisfies this differential equation. But now let's use the initial condition to find the particular solution. So this is a general solution. Now let's find the particular solution using this initial value, this initial condition. So now, we know that y of 1 equals 5. So that means y of 1 equals 2 times 1 cubed plus c must equal 5. And so now we can solve for c. That's what it means by finding the particular solution. Okay, so now, well, now what do I get? I have what? I get 2 plus c equals 5. Which means c equals 3. And now my particular solution is y equals 2x cubed plus 3. And so that is the solution to the initial value problem given. Okay? And that's how it's done. So out of a family of functions, this is the one that satisfies with this initial condition. If we didn't have the initial condition, then this is the best we could do. But since we're given this initial condition, and it's what we call an initial value problem, we can find the particular solution. And that's it. Have a great day.